Dear friends, today we are going to discuss about important topic of metrology and measurement, particularly about measurement of power. So in this video, we are going to discuss about various methodologies, various tools used for measuring the power. There is a force, power, torque. So in this video, we are going to elaborately discuss about the devices used for measuring force, torque, and power. The force, all we know that it is mass and acceleration. Here we can have two types of forces. One is a pull, another one is push force. There are different methods to measure the force. One is a direct method, another one is indirect method. The measurement of acceleration of a body of known mass which is subjected to force. That is based on the deformation of elastic member. We can measure the force by means of balance. In day-to-day life, we are coming across some balance. Those things are called measuring devices. Unknown forces can also be measured. There is a main aim to measure the unknown force. Known force we need not worry, that is we can calibrate. Only for calibration we can have that topic for known weight. The unknown force can be easily measured by various balancing scales and cantilever beam, proving ring, strain gauge, load cell. Many devices cells are there, load cells are there to measure the force. The direct method, there are four ways we can measure the force. One is equal arms beam balance scale, unequal arms, multiple lever, and pendulum scale. We will discuss one by one. The equal arm balance, the diagram goes like this, as we are saying in almost in all the places, wherever, whenever we go to the shop, we can see this type of equal mass balancing equipment. This is one way of measuring. Another one is unequal arm. This is used to measure heavy weight. If you look at this, here we have load arm A and power arm B. This is the way of measuring the force by means of unequal arm. The multiple lever system, that is also used in many places. This is a multiple arm. Here we have the formula W equal to AC by BH into pan weight. That is so look at the diagram carefully. A multiplied by C. The bottom we have that C, the distance. A, the distance. AC by BH into WS will give the unknown weight. This pendulum scale, this we are we know about this pendulum scale. This is one way of measuring by means of torque. The applied torque will make the revolution at the rotating the pointer, and finally will get the reading. That is called pendulum. So these are the four methods used for measuring the force, called direct method. Now in the indirect method of measuring force, we have proving ring, spring balance, hydraulic load cell, pneumatic load cell, strain gauge, and Bourdon tube and bellows. These are the different methods for measuring force. The proving ring method is the famous method. It can be used for calibration of tensile testing machine. It is mainly used for calibration of tensile testing machine, as well as it is used for measuring the force, tensile force as well as compressible force. Both the tensile and compressive force can be measured by using this proving ring. The proving ring, the name suggests that it is in the form of ring. The ring is made up of a special alloy which can be distorted or deflected when the force is applied. Here we can have micrometer, that is a dial gauge we can have, or LVDT linear variable measuring method also can have for more accuracy. Here we have this micrometer fitted with the inside the ring. The ring at the both ends we have the cells, and in some proving ring we will be having the strain gauges. Using 4 different strain gauges we can have the measurement, accurate measurement also we can measure using the proving ring. So the proving ring, as I have told, the the latest proving ring is having the provision of having linear displacement. Using that we can measure very accurate value of the force applied on this. The measurement of linear displacement ranging from a fraction of mm to centimeter can be done by using LVDT. The displacement to be measured is applied to the movable core. Here we have the primary winding and 2 secondary windings. Due to the differential voltage will be produced at the output of the LVDT. See, if you have more on this, when the force is applied on the loading boss, that is in both the ends, that is top and bottom ends, we have the loading boss. The ring tends to distort, and this distortion is directly proportional to applied force. This distortion can be measured by using this LVDT. The second method is a spring balance. By using the coil spring, we can measure the deflection, and that can be converted into a force. That is the force applied on the spring at the free end with respect to spring stiffness K. That is known one. The displacement, that is X, is given by the equation force equal to K into X. That is the stiffness into displacement. This is a spring balance. We can have the direct method. See, here the scale, the slot fixated. This is a coil spring to hold the spring balance. Here we are applying the weight.